Oh, easy.
That's it.
All right. Okay.
Oh, and all I gotta do is pointer is this.
That's the laser, isn't
Yeah.
it? Easy.
They're gonna put yours up when you come up. You don't have to now see.
Welcome everybody to the beginning of our festival of plastic. You know, we did glass, concrete, metal. We were always dreaming of doing plastic. It was like we had to pay our dues and think through the classic materials of architecture. If you say to any architect, what's the stuff? Probably they come up with glass and steel and concrete. Maybe if you're from Scandinavia, you say wood. If you're from Japan, you say time. And you know, if you really catch the spirit, you say something like light, which is what we will do next time round. And we think it's very, very, very important to just treat light as a kind of core responsibility and opportunity for architects and engineers, historians, and so on. But plastic, it's actually not the one that you normally get the reaction, oh yeah, plastic is the one. So what especially excites us about plastic, and I think we've had more excitement about this conference than any of the others, is exactly that in this moment of time, nobody quite knows what to say about plastic. Of course, this in the 60s, late 60s and 70s, we really did know what to say about plastic, and it was a huge part of architectural discourse. And I'm sure we're going to do some analytical work to try to rethink that again. But I ask you just to carry out a sort of a thought experiment, which is you probably think you know like how much plastic there is in the world and to what extent you live your life in plastic. But I have to tell you that by the end of this conference, you will realize, even those of you who are plastics experts, which is a lot of you will realize that you have totally underestimated the extent to which you live in a plastic world, and therefore you've totally underestimated your responsibility to think through what that would mean, depending on what your position is. If you're a philosopher, to think what would it mean philosophically. If you're a technician, technically, as a designer. If you're a social activist, what does that mean in terms of activism? If you're into new forms of communication and technology. In other words, each and every one of our forms of expertise should be displaced by what you're going to listen to over the next 3 days. This conference will be like the previous conferences. Our attempt to just for a moment in time, in this case for 3 days, try to gather together some of the smartest minds and most creative minds and think the question plastic with an incredibly open mind, but drawing on all of the expertise and all the reflections, and see what it is that we can all discover together, and hopefully all leave at the end of 3 days with a sense that there are a whole series of questions that we have yet to work on, whether we are scientists, historians, engineers, technicians, designers, and so on. But this is my challenge to you. You have no idea the extent to which you live in a plastic world. You have not even begun to think this question, which is interesting because you just came to a conference about plastic. So the issue would be, what the hell are you doing here? Like, what did you think this was going to be about? And I hope you find out that this conference is much more than you had thought. As always, the only way we can do this is collaboratively. So not only do we bring together experts from so many different and diverse fields, many of you who we hope are meeting each other for the very first time, but we also do it collaboratively within the school. More than anybody else, I must thank Professor Michael Bell, who is the sort of brilliant conceptual leader in thinking through this series of materials conferences. Michael has consistently raised the level of debate. For 4 years now, panelists have tried to understand what it is that he's asking for them to speak about. And in their attempt to demonstrate to Michael that they're not stupid and that they understood what he meant, they've delivered a stunning papers, usually based on thought that had nothing to do with what Michael was thinking about, but Michael's degree of seriousness, of taking absolutely seriously each and every panel is to me, he's really a role model of how to think through this mission, which is to raise the kind of academic quality of our thinking in these areas which at first should seem so basic and so fundamental. Starting points. This conference is about rethinking our starting point. And of course, when you rethink your starting point, you actually do the most experimental work of your life. But we can't even do it with Michael, with Ben Prosky, who has always been remarkable, and many people that have been involved, the scientific committee, Paolo Antonelli at the Museum of Modern Art, Jean-Louis Cohen from IFA, Laurie Hawkinson from our faculty, Juan Herreros, also from our faculty in Madrid, Stephen Hall, I'm proud to say of our faculty, Christian Meyer, Chair of Department of Civil Engineering, George Middleton from Middleton Associates, who works with the Vinyl Institute and many other organizations, Sylvia Moore, who's Director of Technical Development at Shintech, Jesse Reiser, great architect teaching at Princeton that you know, Felicity Scott, uber brilliant historian and thinker and Director of the Curatorial and Conceptual Program here at the school, Werner Zoberg, one of the engineers of our time, but also director of what used to be Frei Otto's Institute of Lightweight Structures and Conceptual Design. That name already tells you why it's so much fun to be working with Werner at the University of Stuttgart. Heiko Trump, engineer and principal of Werner Zoberg Engineering Design, and so on. This is an amazing group. Just a conference with those people would be just fabulous. But it goes beyond that. We work very closely with Dean Finiowski of the Engineering School and with the Institute of Lightweight Structure and Conceptual Design in Stuttgart. And I think especially importantly, we work with the Vinyl Institute. And as you know, we always see these partnerships with those whose sort of life's role is to take care of these materials and to move those materials through the world. We see partnership with those people as the greatest honor to the school, and I think we are in a moment of the history of our world in which cities, to say it simply, are changing more rapidly than ever in the history of the human planet. More people are living in cities than ever. There will be something like 85% of the world will be living in cities in the next couple of decades. So cities have become the single greatest experiment in human history. And therefore, the questions that face a school like ours, which is dedicated to the future of cities, and the question facing those who manufacture materials, whether it be concrete, glass, steel, plastic, and I would say light, the questions are the same. In other words, we face the same questions, and we are equally infantilized in front of those questions. In other words, it's perhaps possible that the city of the future, of the near future, the city of 25 years from now, is going to be an extremely alien place. We know less about that city than we know about Mars. In both cases, going to Mars or going to the city of the future is something like science fiction. We're going to these places very, very fast. It's perfectly understood that if we wanted to land on Mars, we would need pretty much every discipline available to think it through. Every aspect of the university could be deployed to make that successful. I think that's even more true of the question, what is the future of our cities? Whole universities are needed now to address that issue. What could be a more important issue for a university than what is the future of cities if 85% of the planet are occupying dense urban places? So for those who are providing the infrastructure of those cities at a technical level, at a political level, at an economic level, we are all now together facing this enormous question. So this is why I say to work with real experts, in this case with the Vinyl Institute, which play then a leadership role in trying to bring together and gather together all of the advanced field of manufacturing in polymers, plastics of every kind and so on. And of course, one of the big issues of this conference, maybe the only issue in the end, is what is plastic? Because it's not just that you don't know to what extent your world is already plastic. You don't even know what that means. So part of this conference, maybe half of this conference is, what the hell is plastic? And the other half of the conference is, if that's what plastic is, then I'm living in plastic, so then what am I going to do? Like, what's my position? What position am I going to take? So again, I just want to thank the Vinyl Institute for their remarkable assistance in this. And you know, I have to say that every time we partner with a major industry partner, they always feel a kind of embarrassment that they get to represent the wider field. So I have to say we feel equally embarrassment. Like, why could we possibly think as a School of Architecture that we could be grasping the full dimension of plastic? So I think Vinyl Institute and the School of Architecture have stood in front of this question, plastic, with a similar level of curiosity, expertise, a lot of firepower on both sides, but in general, a very, very open mind. We don't have any prediction as to the kind of discussion that will take place, and I would just maybe invite Terry Chadwick, the chairman of the Vinyl Institute Operational Committee, to maybe say a few words and explain why they made that really foolish decision to dance with us around this question of plastic. But again, just to say before we even begin, thank you so much for making this possible.
Thank you very much. My name is Terry Chadwick, and I'm the Director of Sales for Formosa Plastics, one of the PVC resin companies here in the U.S., and also happen to be the chair of the Vinyl Institute Operating Committee at this time. And just thank you very much for having us here. We're very excited about this conference and to participate in it here at Columbia University, and very proud to be the sponsors of this along with Columbia. We're heavily involved now with architects, engineers, and designers on a regular basis, and we feel this is a new step and a new venture that's going to be a lot of fun and very educational over the next couple of days. We get involved now in AIAS competitions over the last 5 years. I believe there's a slideshow out behind the registration that will show you some of the projects that have been the award winners over the years. We also get involved with solar decathlon is a new one. We have some students here from that project as well. And then also things in the past like Up House, where we met a guy that's, I believe, a professor here now, and Craig Connick, and he's also a great tour guide. He was nice enough to show a bunch of us from out of town around some of the new architects going around in New York, and that was a lot of fun. But we do a lot more than sponsor. We have people involved with the Vinyl Institute that do work for us. Previous mentioned George Middleton. I want to meet as many people as I can during the next couple of days. The 3 people I'm going to introduce are the people you really want to make sure you get to know here over the next 3 days. One is George Middleton, who's an architect who does a lot of work for the Vinyl Institute and Achieve Green and webinars, some educational things that are very useful as well. George, if you can stand up and just so people know who you are, that would be great, because he's invaluable to us. Another person, another architect is Jane Rohde, who's an expert in healthcare and design, and the great thing about these people, they not only bring great things to the VI, Jane, thank you, but she also gets us introduced to people like Michael Graves, who's going to speak tomorrow night, and I'm really looking forward to tomorrow night's lecture from Michael. And then we have Terry Murphy, who's our training expert. Terry, if you want to stand up. Terry does well over 200 training seminars a year, mostly at architect firms, also interested in doing some work with students, doing more of that. And these people are the people that you really want to make sure you say hello to over the next 3 days. They do a phenomenal job for the Vinyl Institute. You know, as we move, if we look at plastics and not just vinyl, and I've been involved in other plastics in my career as well, really what we're faced with is a lot of things that have been constant change. When I look at excellence of manufacturing and things that we strive to achieve here as manufacturers of plastics and polymers. But there's been a lot of change still going forward in recycling, where I think we're just, you know, all plastics are basically recyclable, but we got to figure a way to do it better. And I'm sure these are going to be some of the conversations we have over the next couple of days, including life cycle analysis. And it was amazing to walk in today past where all the work that a lot of you students, I know there's a bunch of students in the audience, did on the history of plastics. And you look back and you see lacquers made in China in 1000 BC. You see in 2009 somebody graduating with a degree in life cycle analysis. And you see things continually going on, and yet I feel like we're just scratching the surface. And I think that a lot of that will come out hopefully in the next couple of days, in architectural and engineering and design, that it's just not the great things we have in again, all plastics, but whether it's vinyl pipe bringing us clean water to drink, or a vinyl blood bag that's helping save our life, there's still a long way we can go. And that's really what brought us the Vinyl Institute here. And we're just fascinated to be here, totally excited, and very thankful to be here as a sponsor. Thanks very much.
Just a few words of welcome to Greg Lynn. I mean, for me, it's just sort of amazing and a sort of a not so secret pleasure to have two keynote speakers, one of which is Greg Lynn and the other of which is Michael Graves, which brings the three of us back together. And this is just something you don't need to know about, but this is what I told you. Yeah. So, but somehow that little circuit means a lot to me, more than just as a kind of question of personal history. I think why I was so thrilled that Greg was willing to be the keynote speaker, which is kind of a difficult thing to do when 42 people come after you to clean up the mess, is that Greg is just without doubt, in one of my minds, one of the great teaching architects, by which I mean not only is he just a wonderful teacher as such in the classroom, but there is something in the work that enables the teaching to be so good, which is already a kind of a teaching. And so everything that Greg does, in my opinion, sort of always has an implied use by someone else. And I was super impressed with Juan Herreros' definition the other day of what it means to do scientific work. And he was explaining to perhaps future mayor of Barcelona, that the mayor had to understand that the projects were scientific, and what that meant was they were done in such a way that they could be picked up and used by someone else. And I think in every possible sense, Greg's work is in that sense scientific. That is to say, it's been set up in such a way that not only can it be picked up and elaborated by somebody else, it's just really hard not to pick it up. And I think, so Greg has perfected the art of making something, whether it be an idea, an essay, or a project, or even just a single word, and make you want to pick it up. And of course, he knows that once you pick it up, you're in trouble, and you're going to start in dialogue with that thing. And so in this sense, I think really Greg is without doubt a kind of quintessential teacher, not only of his generation, but certainly of mine and generations on either side of him. I think of very, very close colleagues of Greg. These are all friends of ours, let's say, and without naming names, they're very careful to keep their work in such a way that it wouldn't be picked up by others, but would internally grow. And I think it's an act of generosity on Greg's part to position the work always somewhere between him and the audience in such a way that they could pick it up and run with it. And I think you'll see this very much today, which is also to say that no matter where Greg is teaching, he's done a lot of teaching in this very room, and I think now is teaching in only 4 places now. This is also in the tradition of a number of other figures in the architectural field who during their entire lives taught in about 3 or 4 places, because their mission was not simply to be in front of one particular group of students, but to create a series of parallel experiments in which each project is slightly different than it is in another project, and as a result, Greg is always working in some kind of a feedback loop. So this is my sort of last therapeutic observation, is that Greg always positions his work in such a way that it could be picked up and lessons could be learned by other people, but he's also positioning himself just on his side of the same object, picking up and learning, and you get this double feedback loop. It's pretty exciting, very, very beautiful work. I think we're very lucky that Greg is going to speak with us tonight. Great.
Well, so because of my history in the building, which is just, to be kind of autobiographical, but more so because I don't really have 45 minutes of plastics. I have maybe 35 minutes of plastics. I thought I would go back a little bit and try to connect what's been, I think, a fruitful but slightly troublesome alignment of digital media and digital technology with plastics. And I was teaching in the paperless studios here at Columbia maybe, I don't know when the first one was, probably 18 or 19 years ago, I think. And at the time, there was a real excitement about the media, which within a year or two started to focus on how are we ever going to get this stuff off the machine and into the world. And what's funny is we didn't go to glass or steel or concrete or wood. Everybody started thinking about plastics. And then 3D printers came along, and people started to say, well, how are we going to get a 3D printer big enough to print out buildings? And there was this assumption that plastic was the solution for the digital media. And at the time, it was a little bit of a problem because I personally wanted to avoid the idea that a building should be monolithic and seamless and printed in one shot, and a lot of these kinds of things. I was very, let's say, initially hostile to a question of plastics. And what that caused me to do was run a little bit into what I think I would call digital tectonics, or trying to think through a classical paradigm of architecture with digital technology. So what I thought I would do is spend a few minutes talking a little bit about tectonics and how the digital media has engaged with conventions of architecture and construction, and then try to introduce some principles of composites and plastics, which I think are actually raising some issues which maybe tectonics can't answer. So that's why the title is Goodbye Tectonics and Hello Composites. Okay. And is there any water? I'm going to need water. If anybody could just give me water. I don't need it right away. But I will need it. I know I'll need it. Okay, so to talk a little bit about tectonics, I know some of my friends from the worlds of composites. It's a little bit of proof of the hypothesis that somebody that comes from the world of composites doesn't know what tectonics means. So tectonics is, and I didn't see Ken. I was looking for him very carefully. But I don't think he's in the room. But if he is, correct me because I know I'm wrong. Tectonics has to do with how things get put together. It usually involves a series of discrete layers. Now, those layers aren't discrete in terms of geometry or space or form. They're usually discrete in terms of materials and also in terms of mechanical systems of attachment. You're a hero. And one of the things that I'm developing a real sincere hatred for is bolts, nails, screws, all mechanical fasteners. And I would just say glue. Like if that's the one word, I'd say this, it's not plastics, it's glue. So, but tectonics really believes in the mechanical attachment. It fetishizes the mechanical attachment, and detail in architecture in a tectonic system is always trying to resolve two different materials coming together or two layers of materials coming together. And that's why tectonic architects so love their bolts and welds and screws and nails and things like that, because they're happening where things are being brought together. So in a tectonic system, the detail is the thing that resolves. And I'll show you in digital tectonics, the details just form a kind of cloud. Now, the thing that's maybe the most provocative for the students in the room is that in a tectonic system, geometry is a thing that makes everything relate one to another. So it's always this geometry which is totally sacred. Doesn't have to be Platonic geometry, but realizing the geometry and the layers and the discrete connections is always the agenda. So turning lines into building components is where the tectonic action is. And I'll tell you, 99.9% of students around the world in graduate schools of architecture are using digital tools, but they're using geometry the way a tectonic architect would. And if there's anything I'd like to change and provoke tonight, it would be letting go of this idea of realizing geometry in built form that comes out of this tectonic tradition. Okay, so the Semper drawing, maybe the most cutting-edge tectonic image I could find, which shows tectonics not as solid masonry components or panels, but tectonics as woven materials. And I think the idea, though, of connections, layers, details that resolve disparate materials, the role of geometry, organizing all these disparate layers. It doesn't have bolts. It has lashing, which is why I like this tectonic over another one. But nonetheless, it's still a method of assembly with discrete layers and discrete systems brought together holistically through a controlling geometry. Okay, so to go back, I think it honestly is 20 years. This was the very first thing I ever used animation software with, and it's very funny that this weekend-long experiment for the Triple Bridge Gateway for the Port Authority, whenever that was, in the early 90s, brought out all the problems of digital media, and it also suggested the solutions almost immediately, which was using these animated paths to turn into curved tubes of structure clad by doubly curved surfaces. And for me, I'm only showing this because in a very brief period of time with a technology which to me was totally new, my first response was how to translate this into a tectonic system, a system of structure with cladding, and with cladding that's subdivided and connected with seams. So again, I think the kind of digital tectonic, which I saw there are 2 conferences in Europe going on this week called Digital Tectonics. It really seems to be the dominant response, not composites. At roughly the same time, a few months later, the hydrogen pavilion for the OMV in Vienna, similar idea, this time just in terms of blue lamb beams, and again, curved surfaces that connected across them. But it was a different formal language, a different method of generation, but nonetheless, for me, a conventional architectural response. Okay, so this contemporary approach to tectonics that looks at surfaces, instead of looking at modular frames and grids, it tends to look at surfaces and tubular construction. There's definitely a branch that's looking at ornament and decoration, which I'll show you some examples of. And then there's also what, at various times, I'll try not to get too bogged down in all this, but an idea of variation and controlling changes in dimension within a set of forms, which I'd call primitives in variation, or at other times, intricacy. Okay, so first the curved surface and tube logic. Instead of thinking of structure in terms of columns and beams, this was a bad idea in the sense that it was a house designed for myself and my wife, which both of us should have known was a bad idea to do. We spent a few months to realize that idea. But anyway, it involves looking at structure not in terms of columns and beams, but a continuously rolled tube, steel tubes. And those continuously rolled tubes, then when they were connected, formed these volumes that cut courtyards into the house and cut these kind of solids into the house. But the approach to the envelope and the volume was again looking at these kind of rolled curves rather than lineaments, and lofted surfaces instead of kind of cladding envelope. But nonetheless, everything sorted itself into these discrete systems of structure and enclosure. I also started to think about molding, and I think probably, I mean, it was in the air. It was really with the painter Fabian Marcaccio, who's here tonight, that I really started to think in terms of figure and ornament and plastics. It was one of the first plastic things we'd done, which I'll show you. But also these new tools that were associated with the digital media, things like CNC routers and printing equipment, started to make us think about how to approach a surface as a sculpted relief rather than as a simple skin. So in a whole variety of ways, using the path of the tool to generate some kind of texture. This is as ornamental as I ever got, although I can tell you there's some pretty crazy CNC ornament around. But the idea of integrating elements into these surfaces, which this is a showroom in Stockholm for Pretty Good Life, where the pegs for the shelves, which could be moved around, were integrated into the skin. You know, the skin became a thing which started to take on a kind of 2.5 dimensional relief. This is probably the most extreme version of it, which is the Predator, which is an installation that I did with Fabian, where we tried to turn some of Fabian's, sorry Fabian, I don't know how else to say it, kind of 2.5 dimensional paintings into 3-dimensional volume you could walk through. And we printed on PET acrylic, or PET plastic, some of Fabian's paintings, cut foam molds, vacuum formed those pre-printed panels on the molds, and then wired them all together into this freestanding monster at the Wexner Center. And the texture of the paintings was translated into the relief on the plastic. So there was both the image that was on it, but there was also the texture that kind of half correlated to the image to give you this quality of a 2.5 degree surface. And the conference room, an office building that used the same approach. Okay, so the tubes and the surfaces, I think the ornamental relief, and finally the last thing I would say would be the variation of components were all things associated with a tectonic approach to construction. The term primitives and variation really comes from a biologist, William Bateson, who had this idea that things that shared a genetic code had the same primitive and that they unfolded differently. And I think the best example I have of this is a series of flatware I did maybe 8 years ago or so, and it was done for Alessi. And Alberto Alessi said to me when we started this, Greg, you should just do a spoon, make the perfect spoon, and then bring the spoon back to us, and then we'll be able to take that spoon and turn it into the fork and the knives and all the serving sets. And I said, well, how many pieces will you do? And he said, well, usually we do, I think it was 42 different elements, from, you know, cake servers to fruit spoons and all that stuff. And I realized they were going to have all the fun. I also realized he didn't really know me. And so I said, you know, I'm going to come back with something else, but great. And on the flight back, I did this little diagram that pretty much said the first thing to design is the primitive, which is this thing, and make sure to put in that thing all of the form I would need to make either a spoon or a fork or a knife. So I needed to make you know, a piece of geometry that had a sharp edge and tines and a bowl to it. And I designed all those things in an animation package and targeted each one and set up little sliders where I could start to mix some spoon with some fork with some knife and come up with all of the stuff that would be in a classic collection of flatware. So this is experiments to make the primitive. So this isn't flatware yet. This is just making the proto-flatware object. So, just running through to try to find, things that would be flat, things for pouring and ladling. And then this started to be the actual elements of the collection or of the service. And I think what's important is that there was no original thing that was then modified to make the others. It's a family. So all of them come from the same object, but none of them come from the same typology. So when you see them, that you can tell they belong to the same family, but there's no one that's primary or secondary. And now whenever I look at flatware, all I can look at is the spoon, and then everything else looks like a bad version of a spoon. Like the fork looks like a bad spoon, or the knife looks like a bad spoon. So I was trying to get past that quality. And I also, we educated ourselves on, reading things like Emily Post on, what forks had 3 tines versus 4 tines and 5 tines, and what a cheese knife is, and that's, whoop, wrong button. It's been a little while, but that's for cream chip beef, that's for strawberries, that's for nuts, that's for soft desserts, etc. That's for serving meat, that's for oysters. So anyway, we made 42 of these objects, all of which are in the same family, and all of which are variations. And the digital tools let you do this. I think you probably wouldn't have ever thought it without the digital tools, even though Bateson did in 1890, thinking about animals. But as a designer, I don't think you'd have the idea to make a family of objects which all relate to each other but are not derived from one another typologically. And so you can obviously see the implications if you're thinking about a system, like a cladding system, or a structural system, or an interior wall system, or a furniture system. And I think this kind of approach lends itself to variations within one layer of a building. It's, in my opinion, this approach of variation and primitives, as well as a parametric approach, is very difficult to think of in terms of composites. It really pushes you towards tectonics, curiously enough. I would at least make that as a provocation. I'd be more than happy to be shown that I'm wrong. Okay, and that's really the basis of a kind of intricacy. So here, each one of these elements of the stairway of the Korean church in Queens is different in its overall form. Each one of the steel pieces is different in its dimension and angle. They all have custom details. I think all of the intricacy gets buried in the steel connections, and all of the variety happens in the details. On the interior, every one of the panels is unique. They all work together rhythmically to focus you towards the altar. But it's all about tectonic variation. It's all about these panels and components changing in a series. Okay, so that was more than 10 minutes, so I got plenty of plastics now. So a few of the ideas I want to talk about in terms of composites. The first is an idea of surface minimalism. And that really has to do with using surfaces to do the job of what was previously one or more components. I'll just illustrate these things. The idea of coincident surfacing is about not geometry. It's not about wireframe. It's not about geometric points in space. It's about using surfaces to organize different components of a building. The third thing is to talk about load paths, so an approach to structure, which really looks at the structure of surfaces and loads moving across surfaces and shells. The fourth thing is a dynamic ergonomics, so an ergonomics which is not planar to the ground. And then finally, some ideas about using the way a core works in a thin shell and blowing that up to the scale of a building and approaching a building as a structural core. Okay, so the first thing is surface minimalism. The best examples of this I have is actually product design, like furniture. And this was a place where I realized that my tectonic ideas weren't going to have much currency. Like in the building industry, where we deal with tens of thousands of elements at a minimum, even just for an interior, to be able to show up and say, look, I have this computational power and this digital vision, and I'm going to make 10,000 pieces that are all different, they're all going to come together, and they're all going to be unique. In the building industry, people get excited about that. When you go to Vitra and you say, your chair that's made out of 8 pieces, I'm going to make out of 10,000 pieces, and they're all going to be different, they're all going to come together, they look at you like you're an idiot. I mean, they don't think that you're being innovative. They think you're actually being regressive. So the idea of reducing the number of components, like Werner Panton's chair, which took what was a chair made out of multiple elements and made it out of one shot of plastic. Actually, it was multiple shots. As they refined it, it got to be made out of one piece of plastic. That's what the furniture world thinks of as innovation. So I tried to respond to that. It tends to involve the integration of elements on a surface, a curved surface usually, and the idea of multiple orientations. I'll show you just what I mean with that visually. And I started off thinking about this in terms of Baroque, very late Baroque architecture. This is Vitone, but you can see the way all of what would have been discrete components are here modeled and surfaced as a kind of single surface, just using a brick. So, one material, a brick, which is able to produce columns and cornices and vaults and apertures. That's kind of the idea. The first thing that ever came to me with this was Greg Foley connected me with a guy named Hedi Slimane, who is running Dior Homme. And Greg does the Visionaire magazine series where they sell these issues of magazines for like $500 based on super exotic cases for the magazines. I got on the phone with Hedi Slimane in Paris, and Hedi said, I've looked at your work, and I love your work, and I want you to have so much freedom and excitement on this project with me. I'm so looking forward to it. There's only a few things. Make it a rectangle of exactly this dimension in cool gray number 3, and there could be no visible signs of attachment, like hinges or clasps. And so I got off that call, wondering what I was going to do, and decided to do that. So the magazine is here, and this is half of the case. And the way the case works is there's a plastic vacuum-formed insert into this powder-coated aluminum case. And the edges of the case bite together in one and only one way. And you can only lock it into itself absolutely vertically. And the magazine floats on these little ripples inside the case. And so when you close the case vertically, it stays closed, and you can roll it around, it doesn't open. So we eliminated the hinges and the clasps by modifying the contours of the surface and making these two surfaces bite together. So this was the first place I had this idea to take mechanical hardware and mechanical methods and try to have surfaces do that work. In the Vitra Ravioli chair, we have a plastic top, but it has to be plastic because it has to go through a computer knitter that, like, the dimension over the arms is more than twice the dimension along the front. So there's more than twice as many knots here as there are there. So it's a 3-dimensionally knitted top, like a brassiere or something. When you hold it, it doesn't really hold its shape. I'll show you a chair that does do that later. But it has a 3-dimensional contour. And then the base is fiber reinforced plastic, which is then painted. And the base does what the legs would have done in one surface, and the bucket does what the arms and the seat and the back would have done in one surface. And then there are layers of laminated foam inside. There's 3 layers of foam of different densities. But so the idea was to make a chair that looked like it was 2 surfaces, a hard surface and a soft surface. So instead of having all these components, you really just had 2. Inside, it's more than 2, but that's the idea. With another Alessi project for a coffee and tea service, I was told that I should 3D print something and give it to the Alessi factory, and their artisans would then reproduce the 3D print in sterling silver manually. And the budget for that was $70,000. And so I went to the Yellow Pages and found superformed titanium and found out I could make superformed titanium pots for less. So what we did is took these two titanium skins, welded them together into a pillow, and cut a mold out of graphite, and then put the two skins inside the graphite mold and heated it to 1,000 degrees in a 0 atmosphere kiln. And we, I mean the superformed titanium people, called high-tech welding. And they put argon gas in it and inflated the titanium when it became plastic, is what they referred to it as, when it started to form in a continuous way. And then they would put a little oxygen in and light it and drive it into the mold the last little bit. But we proved that we could do it in plastics, in just ABS plastic on MDF molds that we made in my office. But we got better resolution in the titanium than we got in our vacuum-formed plastic on MDF. And the one thing that Alessi said is, which his one exception was Michael Graves and Philippe Starck. He said, other than Michael Graves, and I guess Hans Hollein, all architects don't put handles on their cups or their coffee pots. They hate handles. And he said, we always burn ourselves, and we get complaints from our customers, and we always have to add the handles, and we fight about it. So please design the handles when you bring the design to me. So what I did is this and this are the handle. So there's an inner flask that holds the hot liquid, and then there are two textured skins that are bonded to that flask with silicone, so you could put piping hot liquid in and hold it anywhere you want without burning your hand. And the double orientation ergonomics of this are that the tray, which we forgot to design until very late, that's why it doesn't have the texture. The tray is set up so you can flip it. So when you have hot coffee and tea and milk, it sits on the tray vertically. And there are little places where each of these flasks nest. But then when it's empty and it's sitting on your coffee table or in your museum, you flip the tray around. You flip the tray around and they lay open like a flower. So, and the backs of the grips, have a contour that corresponds to the underside of the tray. So the tray has two positions in it. And that got commercialized into these cups, where again, the handles are are made by the volume between the hot liquid and what you grip. So it's like a Turkish coffee cup. And these little things all kind of nest together. So it's like all handles. Each one of these, conceptually has like 120 handles on it. Okay, so this idea of a surface that works as structure, or a surface that works as ergonomics, or a surface that works as, arms and seat and back, where you take what would have been multiple tectonic elements and satisfy those with an idea of a surface, is to me what's the beginning of a logic of composites. And I would just say that certain paradigms, like a monocoque shell, which you'll hear thrown around a lot, you could really treat a monocoque shell as a tectonic system. So this doesn't really have anything to do with a particular model of structure. I mean, so here is a monocoque shell of a, classic wood boat. So the planking of the boat is connected to the rims, or to the ribs and the keel. It's working as a shell, but it's tectonic. It's not a composite. So I'm just saying that to be careful about how you think of these things in terms of structure. This is also a recent tectonic and Teutonic car, which also is built as a monocoque shell. But it's still tectonic. It's still, the shell's doing work, but the shell's connected to a structure which is mediated by geometry. Okay, so for me, the real shift towards plastics and towards a composite is, instead of thinking of a surface on a frame, thinking of a surface in a bag. And you're going to see the next 2 days a lot of very good examples of how to think of construction as materials put into a bag, vacuumed and cooked. And when you put them in the bag and vacuum and cook them, all of the different layers can have a totally oblique or disinterested registration one to another. And what's so powerful about the idea of composites is you don't have to have a geometry for structure that relates to your panels, that relates to your apertures. They can actually be completely disparate to one another and overlaid. So the principles are that you fuse different materials with different qualities into some form of a matrix. Could be cement, could be vinyl, could be epoxy, could be all kinds of things. The layers are related to other without geometric distinction. You tend to think of a lot of fibers, like reinforcing type scale fibers, rather than members, like columns and beams. The orientation of not just loads, but pattern tends to be based on weaving and fiber geometries. And again, there's no geometric hierarchy. That's what's the most exciting, is you don't need that hierarchy. Here's an example of an object that's been put in a bag and cooked. And I think not only the surface of the hull is what's interesting, but there's very few pieces of metal on this thing. I mean, metal is really the enemy in high-performance race boats just because of the weight. But a lot of the components are getting integrated more and more into a surface. So the inside of this boat, there's nothing great about this boat, other than I could get a picture of the inside and outside of it. But it has bulkheads, so it has structural ribs, but those ribs are all glued and baked right into that shell. So it's not about a change in structural paradigm where this thing is a perfect shell, same thing with an airplane that everybody says is monocoque. They all have bulkheads and ribs and supports. It's not a structural change. It's a change in materials and how materials are connected to one another. So this, Bill Pearson knows, it has a lot of 5200 glue in it and a lot of resin, and it's all baked into a single shell, a single matrix. And you can see the change in a Formula One automobile, which is now the majority of which is composites. A lot of it is also fiber reinforced plastics now because it yields differently than carbon. But all of the history of tubes, starts to change because you're dealing with an object which is being put in a bag or put on some kind of a tool and put in a bag and cooked. So it's not a tube with a mechanical attachment to another mechanical attachment to a bar. It's really these kind of hollow shells. Okay, so one idea to think about is that you're sadly always building everything twice in the world of plastics and composites. You have to make a mold or a tool or a plug or some kind of object to mold on. And with these molds, you can use them more than once. And this was a kind of a fairly simple thing that we did with Bill Chrysler up in Sonoma County, of building this, about 3 meter by 2 meter lantern that had two materials, a translucent chopped fiber reinforced plastic body with fiber reinforced cement lenses to focus the light. And so we built one mold, and you can see inscribed on the mold are these rings, and then we built these unrolled aluminum rings that mated to those grooves, and then we laid up in one pass all the fiber reinforced concrete elements and took those off, and then laid up the fiberglass elements. It's the translucent fiberglass, and then glued them all back together. And the formal quality of the light is that two different materials are sharing the same surface. So, there's one geometry with two approaches to the material. The material doesn't have any geometric relation to that form. It's arbitrary. The coolest material I know is Bill Pearson's load path sails, which we did for the Design Miami exhibition for Swarovski in 2009. And you could see here we made 5 of these sails where we took steel tubes, which weren't strong enough, and laminated carbon fiber over the steel tubes. That way we didn't have to make the molds for the carbon fiber or spars. But so these are carbon laminated steel tubes with a membrane which has Bill's going to show all this, so I'll just quickly say, for anybody that's not going to come to the next 2 days, which I'm sure everybody will, is one layer of a mylar, and then miles and miles of fibers. In this case, aramid fibers they're in gold and red, and carbon fibers which are black, which are then drawn on a 3-dimensional mold on top of this mylar. Then Swarovski, go to a detail. Swarovski then, with a computer setting program, laid millions of little crystals in patterns. There were 5 colors of crystals in different patterns on transfer sheets that were then laid on top of the fibers, and then the sheets were pulled off, and then a last layer of mylar was put on, and then the whole thing is baked. So you get a very, very thin shell, and in that shell are the 3 different kinds of fibers and the 5 different colors of crystal. And so it was a very kind of, very active thing when you started to shine LED lights on it, and the idea is to use it as a shade, outdoor shade material and interior light diffusing and space defining material. There's a detail of the crystals inside this laminate shell. But anyway, it's literally a bag. All this is cooked together in a matrix of resin in a bag. There's a new material that Bill has of strands, unidirectional, very, very thin strands of fiber, in this case carbon and Dyneema laid side by side. It's very fragile, but when you lay it in patterns, 3 or 4 across so it can hold together and cook it, you get this very light, thin shell. And we designed for the Art Institute of Chicago these 2 prototypes, a chair, like a hanging sling chair and a hanging chaise in this material. And you can see here we manually stretched it across a rigid mold and taped it down, did between 5 and maybe 12 layers of this material, putting more layers wherever we needed the structure at the corners. And that's before it's been cooked. And this has resin pre-pregged on it, so thermoset resin is already on the fibers. And then it's put into a bag and heated up with vacuum pressure. So this has already been cooked and it's been taken out of the oven. But so you can see heated up and it sucks the extra resin and sucks the material down tightly on the mold. That's what an oven looks like. And then what's great about it is it's a compression shell under its own weight. So I've always hated tension shells. Sorry to any of the engineers that love tensile fabrics, but they're always one shape. So the only thing you can change if you want to change the shape of a tension shell structure is the perimeter or apertures in it. But they, analyze a rolling ball or different ways of analyzing, but you just get a shape. It's called form finding. I've always hated form finding because I like to be the form finder, not the material. And in this case, the material can take a lot of forms, not any form, but it sits there like a shell, like a piece of architecture, hanging until you sit in it and overcome the compressive strength, and then you start to load the carbon as a tension material. And we had 3 adults and a kid, a little over 800 pounds in this, like at 12:30 in the morning on New Year's Eve, and it didn't collapse. So it's crazy strong, and it weighs, I think we've got different weights. This one weighs quite a bit less than a pound. So, I mean, I would say it's probably in the neighborhood of like 10 or 12 ounces, something like that. And also you can see these little tiny strings that we glued into the laminate. You know, also those are rated for, I think, 2,200 pounds of breaking strength, and it's like less than 1/8 of an inch. So, all plastics. And this is just showing 2 different material types. This is aramid, and those are carbon and Dyneema. Okay, so I've recently become passionately obsessed, to great concern of my friends and family, with boats. Mostly because of the materials, also because it's really great to get out on the ocean with the wind and make things go fast. But in doing that, I've discovered this whole industry of naval architecture, which is crazy sophisticated in terms of everything that moves through the water. But when it comes to putting a bunch of wealthy owners inside those things, it all goes to like brass and wood, and it's unbelievable. And they talk about the thing on top of the boat as the cabin. For better or worse, I'm now getting into this world and trying to make some trouble, and have a couple of naval architects that are, I think they're enjoying it. Either they really need the work or they're enjoying it, or both. But we're trying to transform the way you think about the interior and the styling of boats. And what I found in these, which is fun for architecture, is a sailboat anyway is usually on one side or another. I heard this great story about Philippe Starck when he designed his first boat. The manufacturer said they wanted him to do a boat. He said, I don't know anything about sailing. They said, well, that's why we want you to do it. And he said, well, okay, I'm going to need you to give me a boat in my garden for the summer. And so they brought the boat, and they set it up. And he said, well, I thought these things were always sideways. And I said, yeah. And so they had to build a big elaborate cradle that would put the boat at a 20-degree angle. And he lived in this sideways boat in a garden in southern France for a summer. And I thought, that's a brilliant, you know, that's one of his intelligences, is he really approaches things that way. So we've been looking at how these ergonomics are constantly moving and non-horizontal, and also how you style them so that they look like they move like you do with a car. I mean, you see most cars sitting in a parking lot, and they're styled to look like they have a front and a back, and they move. So anyway, here's some images of some of the boats we've been designing, and this is with Fred Kurubla and Tim Kernan in Long Beach. The first one is a boat, a Suncat for TDIC in Abu Dhabi for one of their island resorts, where people sit undercover and sail around, day sail. And so instead of a cabin, it has this kind of flying carpet of carbon that rests on 6 points and floats on top of the deck, which you can see there. And it also incorporates the cockpit for one person that can operate the boat and sail it. And then the interior is, you know, sculpted and formed a little bit with that sensibility. I think there's a racer cruiser boat did for an individual in Los Angeles, which in terms of the interior is more interesting in terms of how you occupy these 2 hulls, in which you can see here. So all of the surfaces and objects are thought of more like these cocoon-like pods or spaces that you'll be rolling around in, rather than platforms that you'll be standing on. And then, you know, much to the dismay of the last speaker you'll hear on Friday, this is a boat for myself, one hull of the boat for myself, where I'm really thinking of the whole couch and sleeping landscape as a kind of a scoop or a big spoon with these elements that spin and rotate out of the sides of the hull that have all the equipment in it. So integrating the equipment and everything into these fiberglass shells. Okay, and that interior is all happening in this central hall. Anyway, all this styling and everything, it could perform some naval architectural function. It also couldn't. Most of it's above the waterline. But anyway, this world of surfaces and ergonomics and deck plan, it's really making the way I think about buildings change a lot, because there's so much, these are things you crawl over and around and inside, more like a bug would inhabit a surface than a person walking and sitting on a surface. So, which leads me to this idea of ergonomics. So, absorbing equipment into plastic surfaces, as well as thinking of breaking up space with curved, folded surfaces, really comes out of this naval approach. Here's this isn't me, this is Osplund at the waiting room of a crematorium at Woodlawn Cemetery that I saw years ago, where the bench is molded in bent ply into the thin ply walls. But this integration of furniture into the architecture is the kind of thing I'm talking about with this ergonomic, kind of multi-orientated ergonomics. This is a house we recently completed in Los Angeles, the Bloom House, and you can see what's going on here is integrating all of the equipment into the surfaces, you know, the lighting, the fireplace, storage, kitchen, but it's also making a space which is not like a loft, but like a cozy loft or a kind of modulated curved loft. And so in plan, at the living level, there are 3 levels here. The slide's pretty burned out. But the 2 side walls fold around to swallow up this powder room and pantry, and here to swallow this kind of open home office, and then fold around to make this little breakfast nook. So the walls are curving and folding, but they also curve and fold to subdivide the space. So you get a living room, a dining room, and a kitchen, all in one open space, but all modulated by these curved, molded surfaces. In the elevations, all the windows also pinch to a point and snap to this line so that they also have this kind of continuous lineament. The way we absorb the equipment, this is just a digital model of one of the bathrooms where we swallowed up the vanities and the sinks and the mirrors and the linen closet into a surface that was sliced and then molded in corian. And you see a lot of corian around because DuPont lost their patent on it, I believe, 2 years ago. So they're eager to show what they can do with corian that their competitors can't do. And so they really went a long way to develop a way of thermoforming very thin sheets of corian for all the surfaces, all the kind of wet surfaces in the house. But so you can see all the equipment and the door handles and mirrors and everything is absorbed into these molded composite surfaces. The light as well, you know, this is a fire and smoke rated translucent fiberglass lantern. It's about 60 feet long. It has cold cathode tubes in it. All of these surfaces are all plaster over lath and kind of egg crate plywood construction. But you can see here the sense that it's one continuous space, but it's not like a free plan. Like the modulation of all these curves divided up into rooms without actually having to be rooms. So, and then in all the, the individual rooms that are in these kind of pockets, they're still part of the main space. They're just folded into these little pockets. Anyway, but again, like I hate hardware. So getting rid of all the metal pulls and metal equipment and trying to swallow it into surfaces. Okay, then the last thing, 2 more things I'll show, which have nothing to do with this idea of surfacing. One is some flat pack approaches to construction, which I realized were becoming kind of giant cores. And the way a lot of high-performance composite surfaces work is you'll have a skin, which is structural, and then you'll have a non-structural core. Could be balsa wood, could be foam, could be honeycomb or Nomex, whatever it is, and then another structural surface on that. It's just like an I-beam. All you're trying to do is just separate those two structural skins as far apart as possible and just keep them laminated together with the core. But those cores have a character, which I realized we were starting to do at a bigger, at an occupiable scale. Okay, but anyway, it started with this housing project for Vicente Guayar's Sociopolis, where we tried to make in a very small apartment building every apartment a little bit different. And instead of treating it as the units being different, we invented these voids that chopped through the building, which gave the units their character. So you can see these voids chopped through. The voids are what makes each one of these bedrooms different in each one of these apartments. And as we developed it, we developed these super components to try to regulate some of the complexity. So each one of these super components can be flipped, so a window sill can become a window head. It could be manufactured in a factory and brought to the site and erected. So, with 4 different components, you could get a big variety of connections, which this would be more for the metals conference, but look great as lines and started to go very Flintstone in models. I'd worked for Peter Eisenman a while ago, and we did this one model where we painted every surface. Actually, with Mark, we worked on it for the Frankfurt Biocentrum. Was it your idea to shade it? Okay, well, anyway, if you just had a 5-sided block, we just painted each. It was also because Bob Sletsky was always adding gray to our color scheme until we got something that we liked. And so we just progressively added gray. So one surface would be very saturated and the other 4 would get progressively less saturated. It looked like it was lit, even though it wasn't. So I took this idea and for a disco ball said, well, instead of making the whole thing metal, let's say that there's a blue metal, a gray metal, a green metal, a white metal, a gray metal, and actually physically render the building with 5 different colors. So based on how it was shaded, as a way of killing those windows that look so Flintstone. So in this model, you can see there's a gold, a copper, a black, a white, a brushed, and a polished aluminum skin that gave it this disco ball effect, which is, you can't really tell where the glass is now. But so that panel approach started to infect everything, including this restaurant across from LACMA, where you can see the columns, which started off as kind of rolled cylinders. After that Sociopolis project became faceted and kind of, let's call it flat packed, as well as the trellis, which is just a shade trellis. It's not weather tight. Also became this kind of egg crate shell or almost hex grid up there. So this flat pack approach to handling surfaces and facets started to go to a bigger scale. This is the other half of the Design Miami installation, which is the HSBC private lounge. So if you had one of 100 cards, you could get into this place. And they realized that they'd commissioned a very expensive set of furniture that they wanted to have people see without getting in there. So we designed this series of panels so that we could put windows in it everywhere so people could look through it, but it would also be a boundary. And we wanted to get it so that it could fit in a small enough container that it could be shipped to Miami and then shipped to Basel and shipped around. So this has already been in and out of the box 3 times and set up. And it actually fits in the back of a truck. So, like a pickup truck. So it's all, this is a vinyl, this is Sintra panels. which you could pop together with a couple of people in an afternoon. And because of this, we were asked to do pavilions for the Index Awards, which there's an award called Index Designed to Improve Life that happens every 2 years. And they have to ship around a whole set of 90 objects in a series of very large pavilions to a bunch of different design festivals. So these pavilions will get knocked down and put together about 6 times, and they'll do 2 sets of them, and they go Melbourne, Shanghai, all over Europe to Pasadena. They move around a lot. And the last set they did took about a dozen shipping containers to move around. And we've got one set of 9 of these pavilions that'll knock down and fit in one shipping container. So the whole approach to it was to be sustainable in the transportation and setup rather than in the material. And so these are built out of carbon fiber. This is the first one. This is just last week. Sorry, I don't have a better picture, but this is the first one they popped together, and it's a carbon reinforced plastic. So it's like Sintra with carbon fiber in it to make it light. Okay, then the last thing I'll show is the purest expression of plastics I have, which is this plastic brick. And I have 2 kids that are now too old for this stuff, but I noticed that usually what happened when I was gone, that every couple of weeks, one of these things would show up in my house, like a very large, hollow, rotomolded plastic object. I mean, we even had a rotomolded plastic cabin in the backyard at one point. But we kept picking up all these hollow plastic objects, and then we would take them to this secondhand place and sell them, and everybody was very sorry to see them go. And so I had this idea to build a wall in our house out of my kids' hollow plastic toys, where I would use these things as bricks and stack them together. And so the first thing I thought was, what would be the material that otherwise would be mortar if it was a normal brick? And I didn't have a good idea for that. And so then I had the idea, well, what if I scanned them, composed them in the computer, and found their intersections with one another, cut them with the robot, and welded them all together like interlocking hollow bricks. And so that was this idea I had that came out of using toys, my kids' abandoned toys. And so here's an example, here's a duck that we cover in baby powder and scan, and then take that cloud into a computer and compose, and then put that guy. Actually, could you play the movie that I brought? And if you'll just kind of fast forward the movie 30 seconds to where you'll see this poor duck getting, yeah, there it is. So anyway, we intersect these objects and find the curved line that describes their intersection with each other. And then with a company called Machinists in Los Angeles, run by Andreas Frosch, a Columbia graduate, Andreas then programs the robot to follow a path normal to the surface and cut these things up into pieces. And then, yeah. Okay, that's good. You get the idea. Okay, so, there's a great tradition of ducks, ducks and machines in architecture. Just my windows are better than that, I think. But so anyway, then you compose these things together. This is a duck table that we did. I actually won a Golden Lion for this at the Venice Biennale, if you could believe how architecture is fallen. But so this is about 18 ducks together to make this base for a table. And there, in the Bloom house, there was one of these made out of eggplants, I forgot to point out. That's sharks, That's the eggplants. Those are rocking horse dogs as a shelf. Those are whales. It's a coffee table. But anyway, it's hard to get my hands on thousands of these recycled toys. We have a website. We'll buy them from you for more than you paid for them retail. But still, we can only get a couple dozen of each one of these things a year, and we need like thousands. So we invented our own brick. And this is a panelite product called the blob wall, where we make these hollow plastic bricks. Every brick is supposed to be the same. Turns out they're all different based on what color they are and what temperature it is when they're made. There's a lot of variation. But we compose those bricks, find where they're intersected, and then cut one brick and then weld it to another one. And now this is a commercial product of which we've done, maybe half a dozen or more for interiors. This is the thing we did at SciArc, where I just made a giant brick out of bricks. Which has also affected the way I'm thinking about massing. This was a competition scheme for a lecture hall for the ISTA University in Vienna, which has this kind of chunky plastic puppy massing. And then it was my wife Sylvia who I think intuitively thought the right scale for this stuff was fountains. And she kept saying, you have to do a fountain. This makes sense as a fountain. And I realized kind of formally and analytically why that makes sense. So if you take somebody, let's just say Bernini, because I have an image of Bernini, of a Bernini fountain. A Bernini sculpture is usually one or two figures. It's not a whole bunch of people usually. Architecture, like I said, is a minimum of 10,000 pieces of something, in even the smallest example. And what I found is fountains are this very weird formal typology that is a pile of disparate stuff. I mean, actually, when you look at them, ridiculous piles of disparate stuff. So in Triton's fountain by Bernini, and this is here for Michael Graves. I wish Michael was here to see that we actually share a love for Bernini's dolphins. But here there's 4 dolphins with 4 scrolls. You can't see it here, but there are 4 keys, like big keys to the city. There's because it's near the Barberini Palace, there are 4 beehives with bees all over the place with these big shells with Triton holding another shell. So it's this pile of junk, like just tons of figures piled up into an overall shape. And so that's where we've been going crazy with these fountains. So this one is actually a rendering, but that's a fountain that we did this summer at the Hammer Museum, built out of, these are all whales that roll around here, has a whole nautical thing, and these are all sharks. And the sharks have streams of water that they spit out into this pool down here. And that's it being built. There you see the sharks better. And then this is one that we just dropped into my front yard 10 days ago. That's a rendering of it. That's it being fabricated. That's it craning in. I mean, the great thing is also, if you want to know why plastics are great, like imagine if that was stone. So, anyway. And so to close, I'd like to say plastics is more about chemistry and compositions of cooking than it is geometry. And I have this very funny excerpt from a film called The Grand, where a friend of mine was assistant director, and Werner Herzog's also in this thing, and they came by and they said, look, we have this one scene where Woody Harrelson needs to present a whole bunch of casinos and we don't have a budget, so can we borrow some of your models and just pretend they're casinos? And I said, okay, and the thing they ended up taking was the very first model of a brick for a blob wall. And what's funny about the movie is there's a script for the first half where everybody's in character, and it's about gambling in Vegas. And the script ends, and then the second half of the movie is all improvisation. And so they asked Woody Harrelson to improvise an explanation of this casino, which I'll show you now. And for this, we need the sound. But he totally gets it. I mean, he totally gets the plastic sensibility.
I like this one too. It's called Hector's Frozen Cart.
Now, I'm gonna be candid with you and let you know that I don't know what I was thinking when I came up with this particular design, but I was under the influence of cocaine and heroin and marijuana and LSD and mushrooms and some ecstasy. And you know how sometimes you get that cocktail just right and then there's just a boom.
Okay. That's it. Thanks. Questions? Yeah, sure. We have questions? Yeah, sure. Yes. Yes. I mean, one of the things we're doing is for about 3 weeks this summer, we're going to throw plastic over everything and spend 3 weeks milling balsa wood backup for all of those kinds of things. So typically you wouldn't do that. I mean, on a lot of boats right now, because everybody wants to get rid of metal, they're integrating more and more of that stuff into the construction of the boat before they cook it. So in general, you see a lot of soft loops and fabrics and things like that replacing all the metal. But we're even in terms of the forms and surfaces and stuff. Instead of putting balsa wood under the deck, which is what you'd usually do, we put it on top and sculpt it and shape it to give it a kind of formal style. Yeah, I hope. I think it'll be more sculpted than a typical boat. Like it'll be much more. There's much more visual action going on than like that boat I showed you, which has to do more with the design. But yeah, there's a lot of ergonomic parts and pieces that we're molding into it though. And I think all the molds for the interiors will actually form in my office and take to the boat builder. Just so we can integrate more of that kind of level of detail than you would normally do. Johan?
Greg, can you help me a little bit on, you pose basically composites as an oppositional term to tectonics. And it seems to me that's a little bit problematic for me. I don't quite follow it. I mean, tectonics is has been for long an idea about how in architecture one basically coordinates structure and construction with architectural aesthetics. And although, for instance, if it's merely reduced to that of putting things together, which obviously would be a point in terms of how a certain traditional tectonic theory would read also earlier architecture, then it seems to me that even when you look at Baroque architecture, you're suggesting something else is at stake. And although, if I understand your use of the terms plastic and composites, which certainly aren't the same,
Right.
but yet, questions of geometry doesn't go away. Questions of, in fact, with composites, it's basically all there. And, in both cases. And furthermore, it just seems to me that the whole question of coordination just shifts in a very strange way to much smaller scales of material articulation. Questions of putting things together don't go away.
No, I'm not saying, I'm saying it, if you think in terms of tectonics and you get interested in carbon fiber, I can easily imagine an architect building carbon fiber primary structure with little carbon fiber connectors to carbon fiber stringers and secondary structure, with carbon fiber panels, let's imagine bolted onto that, with carbon fiber ducts running behind it. And they would just articulate everything as a component because that's tectonics. Whereas if you look at something like a plane or a boat, the wiring, the channels for moving air and moving lines and moving electronics, the laminate schedule for the structure, the openings, it's all totally disparate. You know, the openings are just punched in, and where you have the openings, you just put some extra layers of cloth at different orientations. So, A, it doesn't have anything to do with the geometry of the fibers relating to the geometry of the overall structure. They're totally arbitrary one to another. And more of the systems get put into that sandwich and cooked rather than being broken down into all these discrete layers. So it's the tectonic obsession with extra layers. And most of where I see plastics going right now is in cladding. Like, oftentimes, additional layers of cladding. Like, you'll see plastics being used as a water sealing envelope that you never see, and then there will be steel, and then you'll see plastics as a second envelope, which makes the shape and maybe controls the lighting, like, say, the Kunsthaus and Graz or something. There's a lot of plastics, but it's broken into these layers that are super tectonic. And only an architect would ever do that. That's all I'm saying. It doesn't really have anything to do with the character of the material. So, but it's tough to change the whole sandwich. I mean, we're used to making sandwiches a certain way. So there's a whole lot of obstacles to making a new kind of sandwich. I mean, that I'll totally acknowledge. But I think, you know, focusing on the fancy little filleted carbon connection and then seeing a bolt, like, makes me cry. You know, because that's absolutely the wrong way to approach plastics, I think.
I can't help but see a sort of parallel between what you just described, actually, and sort of the generation of a organic body, especially in, well, taking the idea of the genetic sort of precursor and the form generation that evolves into, but also your aversion to hardware, where, you know, organic forms are not unfolding to develop into a wheel, let's say, but the forms that are generating are, you know, kind of disintegrating into, you know, bone into cartilage, or, you know, a neural tube is forming into a spine. And so I guess it's a two-part question. Do you think that plastics and composites in the way you're describing them are following an organic kind of pattern? Well, I don't mean organic, I mean unfolding, like organic matter. Okay? And the other question
They could for you. No, they totally could for you.
Okay, well, so the possibility exists, but also then, is the possibility available? So you have these forms, but are they potentially, is there potential for articulation, let's say, in the way you bake something? You know, can you bake two different composites such that what you end up with is not a rigorous shell or monocoque, but a articulated shell?
Yes, I think, well, I do think there are some strong formal consequences to thinking in terms of laminates and load paths and composite materials. I mean, and you know, it was, you know, Bill Chrysler says over and over that reinforced concrete is a composite. And so if you think about the way you can form concrete by adding steel to it or fibers of all kinds, the formal possibilities are different than if you're using lineaments and, you know, beams and columns and disparate materials that don't get baked into a matrix. And like I said, there's a big tradition right now of surface ornamentation that probably also would really enjoy experimenting with these kinds of sandwich constructions. So yeah, but I don't think there's anything natural about any of this.
Well, but what about like the brain, which is a laminate structure and which, you know,
I
is
can't
essentially-
stretch that far.
I'll try. I'll get back to you.
No, you can. You should. I just got into, autobiographically, a whole lot of trouble. Like 20 years ago when I was showing just the curved things with the curved tubes, everybody said, oh, I get it, this is biomorphic architecture. And everywhere I'd show up, they'd say, oh, you're the guy that's interested in biomorphic architecture. And I kept saying, no, I'm the guy, software guy, you know? So I'm more careful about allowing the metaphors of anthropomorphism and biology to stick to this stuff. But that's probably my own thing. You should go for it. And it'll take some of the heat off me.
I was hoping we could discuss for a minute just the use of the mold and the fact that it is this sort of, when you sort of began this talk, you discussed that one of your ambitions was maybe to think about being able to print a building and in one sort of composite. And when you, at the scale you've been working, it seems like the mold is okay. It can still be a residue that you can get rid of because it's on a scale where you can sort of, you can fit it inside another building. But when you sort of approach the scale of architecture again, how do you begin to deal with the mold? And what are your thoughts on the mold as like an object separate from what you have, the finished product?
Sure. Well, I would say one of the things you do is you replace, there's a lot of molds now, like the auger that you roll steel out of, or the table you cut lumber down to. I mean, there's all kinds of standard dimensions and extrusions that we live with every day. A lot of those things can get replaced by a lightweight, disposable, recyclable, integrated, reusable mold on a site or in a factory. I mean, I kind of think that would be the paradigm shift. So instead of buying a bunch of stock material, and I don't have this stuff at my fingertips, and I don't know how reliable it is, but I know 6 days ago I saw a chart that said that 30% of all building materials on average in the US end up as waste because of this whole standardized approach to delivering materials to a job site or to someplace where it's being fabricated. So, the idea of the mold is more that you're doing something which has probably a much fewer cycles associated with it. So if you build a die to extrude aluminum curtain wall sections, that's going to have a lot of cycle time associated with it. That's what pays for it. Whereas a mold that you'd cast, a room the size of a boat on is going to have 4 or 5 cycles associated with it probably before it would get thrown away. So I think it's more like that. But yeah, there are people that have robots you can bring to a job site that'll squirt concrete like toothpaste, and those things exist. People trying to get rid of the mold. I'm not so anxious about getting rid of the mold. I think it's more just how you think about construction on a mold is very different than thinking about construction of lineaments with secondary structure and cladding, and it's a totally different paradigm of construction. Okay.
A lot of the approach we're taking to the sort of material is a sort of desire to have the material have this condition of fluidity or smoothness or multivalence. And I was thinking about what you said when you disliked hardware. I was thinking the actual screw itself, you could call the screw to be not a tectonic but a composite material, and that the ridges and the construction of the individual screw, there's a sort of internal multivalence that the screw itself has on a really, really small scale. And of course, when the screw is used within a context, like you bolt things together, then thus it performs as a tectonic. And then my question is, a lot of your projects end up being like at the scale of the fountain, and that's just an observation, not a criticism or anything. I'm curious to the extent with how you see the sort of the multivalence of your forms or your structures or your creations scaling. How does this scale? And if there's a scaling that happens, then do they end up performing as tectonic the way that a screw at a micro scale is a composite, but scaled or put within a larger context becomes tectonic also? So yeah, how do your objects scale? Have you thought about the problem of scaling, or the question of the differentiation between a tectonic and a composite that happens within a question of scale?
Yeah, I think it's tricky to be at a materials conference because materials do have implied scales to them. I really tried in the talk to say, well, there's materials, but then there's design sensibility. And the design sensibility is totally scale-free. So, I don't know, the way a ramp goes into the entry of a building, or the way, the surface of a multi-story building relates to its interior, that's really about a sensibility of composites. I don't know if you'd actually make them all out of plastic or whether you'd cook a whole building in a bag. That's more material bound. But I think there's a sensibility of design and construction, which of course it would work. I mean, just take the Seagram building and take its primary structure and take a load path curtain wall that's arbitrary to it and laminate it. That's a composite idea of construction using typical steel materials. So I think it could work the sensibility can work at every scale. The materials, yeah, they're probably more, they have material properties that are going to make them work at a certain scale. There's also like the intricacy in everything is, like the thing at SciArc, it was built in a not very accurate way because we had like volunteer student slave labor. And when it all came together and met, like the gaps were enormous. And we realized to do something that big with that much intricacy, we needed a jig or scanner or some kind of thing. There's a lot of limits to how this stuff works at bigger scales. But anyway, it's the sensibility I'm more concerned with, not really the material, to be totally honest. Could be. Yep. You ask Bill Pearson to do your curtain wall detailing and you'll get a composite approach to tectonic construction, which would be very cool. It would not be based on materials. Or you have his engineers analyze the stresses on a tower. They're going to come up with a very different approach to it because they're coming from the world of composites. So, and that's, I think, where the action would be. Not necessarily marrying a material and trying to make it work at every scale. That would be frustrating.
Okay, so I guess my question is to do, with, you had mentioned prior in the beginning about the relationship about plastics and architecture going back to the 60s, 70s, and there's a kind of political dimension at the same time.
I said that?
No. I'm implying the political dimension.
Okay.
About, yeah.
Okay.
I mean,
no,
that's
said
no,
I said
no, I know you didn't say, but right.
Okay.
But I suppose that would be my question is more in line. Like, do you see any relationship? I guess, obviously, yes. The concern is more about the process in a way, about using plastics and the process and the potential. But do you see any kind of like there was a kind of meaning also implied back in the 60s and 70s about what plastic would mean for domesticity and do you see any kind of relationship with your own work with that? Like, is there an underlying agenda that's maybe not discussed? I mean, just a question.
Political, no.
But maybe social or something about new.
Well, I think I have an affection for the surfaces that I think is explicit in all of it, and the whole, at the scale of something ergonomic to the kind of civic fountain. They both address the public realm very differently than if they were in another material, but also than if they were conceived in another way. And I think part of it has to do with being contemporary. I also think part of it has to do with just rethinking conventions. So, I mean, the conventions of how you sit in a chair, I mean, by making it a bucket, we really spent a lot of time studying how you sit in it sideways and throw your arm over one side, and different sized people fit in them, and there's a whole relation to the body and how you drape on it. And the same thing with the fountains. I think, you know, with the Bloom House as well, there's a kind of a coziness and domesticity to it that's, you know, there's a minimalism of absorbing things into surfaces and getting rid of a lot of detail and clutter, but at the same time trying to make very comfortable domestic rooms and subdivide the space. And I think all of that is, you know, related to the design approach and implicit in the design approach. So, and that has a little bit to do with some of the, you know, Joe Colombo and their approaches to taking a whole kitchen and putting it in an object, or, you know, making these, you know, Pantons rooms that are furniture. You know, I think playing with the scale and how you relate to the object and everything, there is a tradition there that happens to have something to do with foams and plastics and stuff.
So I just wanted to thank Greg, who transitioned from being an architect with a sailing hobby to being a sailor with an architectural hobby, and has now, I discovered, found a way to legitimize that to everybody except his family. And so I just want to thank Greg for really getting the conference off to such a great note. If you listen to each of the questions, and I thought they were all great questions, these are clearly the questions that will linger through the whole conference as we push the definitions of plastic and so on. But I ask you just to consider one small factoid, and maybe throughout the 3 days we could deliver more of you. I'm looking at you through plastic. I'm more or less blind without that plastic. It's quite high performance, by the way, dealing with the various problems in my eyeball. And I've had work, you know, I know a little bit about the inside of my eyeballs, unfortunately. But it does mean that I only see the world through plastic, but also so many of the people in the audience are looking back at me through their lenses. Greg was using his versions with screws on them, I think. So,
now I got to design glasses.
But just to have you think, so that if we are together here thinking what plastic might be and thinking what space might be, and even the way we see each other is conditioned by a certain technological advantage offered by plastic, that at least would have you pause, and especially to those of you who are in the room whose plastic contact lenses I cannot see because you do not want me to see them. We are all somehow then suspended in this world that we're going to analyze through the 3 days, and who wouldn't argue that the space between our respective eyeballs is not probably the most important space over which architects have some degree of creativity or responsibility. So it's sort of in that spirit that Greg, through his plastic glasses and the plastic of the lenses of the projector, which gave you that image on a screen, which is, by the way, plastic, et cetera, understand to what extent when we say that we're going to talk about plastics in architecture and engineering, we're speaking about such a large proportion of our world, and to the extent that we're responsible, and in the university we have an obligation to be as little stupid as possible. The only real mission of this conference is to minimize stupidity about plastic, and you did a great job.